is it just Korea or is it globally? Do you think it's a global?
Yeah. Okay. So the short answer is yes, right? So it's certainly something that we would expect from climate change. Oh. Do you need to? Perfect. So yeah, the short answer is yes. This is clearly a telltale sign of climate change, and so it isn't located, just to Korea. Actually, where I'm from on Long Island in New York, actually just last summer received an extreme precipitation event that seems somewhat similar, very short duration. That actually now we still have infrastructure damage that is going to take years to build back, just a mile from campus. And even so, I mean, just to make it, this is how real it becomes for everybody, is we had this rain event happened right when our students were coming back to campus. And so we had to change. There was whole dorms that could not open for the academic year, and we had to move students away from campus because of extreme precipitation, similar to, I think, the events here.
That was last year.
Yeah, it was August, right before semester started. And so can I add just two more things then, based upon what I just said, which is to the other part of the question, is yes, so these type of events that maybe happen historically 1 in 100 years are happening more frequently. So another way to say that would be an event that usually would have happened once a year in terms of rainfall amount might happen 2 or 3 times a year now. And now the events that you're referencing last week in Korea, I mean, these are very extreme events, but that is that you kind of see that change in frequency. And the other way to think about it, though, is that we do see that every time we have an extreme rainfall event, that there is just more rain falling. There's a percentage increase because of the warming that we've experienced globally. And so it's kind of it's the whether you want to look at the change in magnitude or the change in intensity, they're both increasing.
So 이런
I think you should stay with the definition, because if that definition, and I don't know where it comes from, but if that definition is based upon expectations around stream flow or how pipes are designed in cities or how road and infrastructures are designed as a useful tool, then you want to keep that, because what we're finding is when you have a fixed threshold like that, what climate change is telling us is that you're going to have those type of events are going to increase in frequency. And so if you changed the magnitude, it doesn't change the fact that 72 millimeters is a lot of rain to fall in an hour. And so that's what you should be, I think, I'm assuming then, right, if there's a reason for that, then it should, you would want to keep it. Yeah, I mean, I think one potential pathway, we see this with other types of extreme weather events, whether it be typhoons, hurricanes, or in the United States, tornadoes, where we have, and we also with droughts, we have classifications, right, of category 1, 2, 3, or something like that, just to kind of translate that they're all extreme, right? A tornado is extreme to begin with, but there's different levels and different impacts, and having a system like that could help in not only in the communication from prediction, but also it could be that different levels mean different things to different stakeholders or sectoral needs, I guess.
Hurricane prediction.
Yeah. So my general idea is that, at least over the last 4 decades, there has been a general improvement, right, operationally in terms of forecasting tracks of tropical cyclones, typhoons, hurricanes, right? So while predictability might be harder in one basin than another, it's still better in general than it was 30, 40 years ago. And a lot of that's come from the fact that we have higher resolution satellites and all of that. So I just want to start that with there have been improvements. I think the aspect that makes typhoons and even hurricanes in the North Atlantic the most challenging around predictability is actually intensity, right? And that is in part because rapid intensification, which is this process in which storms get strong very quick over a 24-hour period, is really critical to knowing, particularly when a storm is coming close to landfall. And we expect rapid intensification to increase in the future, which means, in that sense, intensity might be harder to predict in the future based upon current capabilities. In terms of, I think in general, and I'm probably saying too much, so if you need to stop, so you can do. But in general, we have seen a shift in the West-North Pacific, right? Poleward shift, meaning that typhoons, when they are reaching their most extreme intensity, is occurring further north, which was likely then impacting regions like Korea more. And so that suggests that there will be more of these storms potentially in this region. And when you start to have more storms, you experience similar to what we have in the United States and the East Coast, which is we go through this every few years where there's a potential storm that's going to make landfall, but then, it 2-3 days, it's somewhere else. And I think that track predictability 4 or 5 days out is still going to be a challenge, and it's improved, but it's still a challenge. And so if you have more storms or experiencing stronger storms, it's just going to increase the challenges of predicting them right in ways that can be useful for preparing the coastline. Yeah, so in short, that remains challenging. So this is, I think, true in the West-North Pacific. It's also true in other basins where, at the beginning of the season, knowing where you're going to have more storms or not that year, or even on the period of looking forward 5, 10, 20 years, it's really hard to know where storms are going to be or where they're going to be more likely. This is probably the hardest thing about not only predicting storms seasonally, but also predicting them on kind of decadal timescales. And so that I think is assessing risk in that way is a challenge. And will continue to be so. Though I want to just step back and say, when we think about risk, one of the things that we do know, right, the evidence is becoming clear on, is that when there is a storm and when it is potentially going to impact with Korea, it is going to be likely stronger and wetter, right? So there'll be more rainfall associated with it now than there would have been 40 years ago, and then there'll be even more in the coming years because of climate change. And so there is, if you're not able to say anything about, there's lots of work. People are really trying, and I think there's even been talks at this meeting, right? They're trying to hone in on regional distribution of storms. It's just a really challenging thing, but we can definitively say that these storms will be stronger and they will rain more when they do happen. And that at least that informs some of your, resilience planning. Yeah, I think I mean, the way to say that is there remains low confidence both regionally and globally around understanding how the number of tropical cyclones will change, right? So this is true globally. So historically, the number of tropical cyclones everywhere on the globe is a relatively stable number. It's around 90 per year. Some years basins like West-North Pacific have more than other years, and it offsets it, but this number is relatively static. Of course, there's variability, but it's pretty consistent. And so that suggests that maybe the numbers don't change globally. But we can anticipate that the number of those storms that are major storms, that at least what we often define as Category 3 or higher, but these are, I think, typically referred to as major typhoons. In the North Atlantic, we call them major hurricanes. The strongest storms, the proportion of storms that are strong is increasing and will continue to increase. But it's really, in terms of the numbers in the West-North Pacific or in this region, it is really hard to be able to say anything about that, how it will change in the future. But yeah, well, and let me just say one more thing, which is, and this is now me maybe being a little bit provocative, right? Which is the numbers. If there was a change, they're going to be relatively small, right? We're talking about percentages, and ultimately, the impacts of typhoons, all it takes is one typhoon to have a lasting impact on a region, on a country, on a town. And if the numbers are changing by a couple of percent over the next couple decades, like, does that really inform risk more than the fact that we know that when we have a storm, it's going to be stronger and it's going to rain more and it's going to have larger surge? And these, like, it's. I think we get fixated on the numbers, the risk, because that's how we define risk. But for me, it's less important depending upon what your business model is. Depending on what industry you are. And the insurance industry cares a lot about numbers. Where if you're a local community or a city, I think you should be less concerned on the numbers. But that's, I don't know, that's a little bit more of a, an opinion.
실제로 이제 태풍 빈도의 specific regions.
Yeah, so that's a really hard question. But I think that the way I'll start to answer it is, first, if we focus on extremes and extreme weather, right? So let's go back to rainfall where we started. That everywhere is going to continue as experiencing now and will continue to experience in the future more extreme rainfall events, right? Because what makes an extreme event here in Korea might be different than in Northern Africa, which is different than, in terms of what is the threshold, back to what we were saying earlier, what defines extreme rain. But what we do see is that for most of the globe, there is an increased frequency in the most extreme events occurring everywhere from a precipitation standpoint. So in that sense, nowhere is really free from experiencing changes in extremes. Now, but to get more, that's just contextualizing the question, but to get more at areas where we expect to see more changes, I think it's, again, it depends upon the extreme event. We know we are seeing increases in droughts. We're seeing increases in heat waves, particularly a lot in the mid-latitudes, right, because of changes in atmospheric circulation. So I think, and heat waves are very deadly. And so I think that you're seeing places like Europe, Asia, and North America that are experiencing really prominent heat waves. But for me, the way I think about this is actually it's where are the regions that get a bunch of these different types of extremes or experiencing compounding extremes in which, and so I think that to me, the areas that are the most susceptible to climate change from an extreme weather standpoint are urban coastal cities that are heavily populated, because you are having changes in rainfall, you're having sea level rise, you're having heat waves and urban heat island effects that are impacting them. And so it's really where we've historically as humans decided to live for commerce reasons, right, which is the coastline, that these are the areas that are the most susceptible, I think, to climate impacts from extreme weather. Sorry, that was a long answer, but I'm trying to actually give an answer as opposed to just claim that it's hard. Yeah, so I think that, the answer is yes, right? Like, in order to become, so the weather is changing. Like, so as climate change, weather changes by definition, right? So I think that's so that means that our infrastructure, let's use that as an example, drainage pipes have been designed to be a specific diameter, oftentimes based upon, right, the type of rainfall that's expected in that region. And oftentimes, that, depending upon where you are in the world, that data is old, right? It's 50, 60, 70 years old based upon the infrastructure. And so I think it's critical to start building climate information into design and decision making around infrastructure. Because if we're putting a lot of money into building back infrastructure right after an event, if we're not building it back not just to be what it was before, but to climate changed world, then we're kind of, wasting money as a society, or not wasting money, but it's not. We're putting ourselves just as much at risk. So I think yes, in terms of warnings around events, I see two kind of key things in the sense that, as the frequency of some of these events increases, I think it's important, right, that communication is being made, right, that yes, we just had an extreme rainfall warning last week, and we're having another one this week, right? This is what we're expecting because of climate change impacts on these type of events, and so it doesn't, or else humans have a nature to kind of come complacent and just, well, we just had one, or when you have warnings and then it doesn't happen, right? Then the next time they don't heed the warning, and so I think it's important to be consistent with warnings, but also we have to think about. And this is probably true in Korea. It's definitely true where I'm from in the United States, which is the types of extreme events that some regions may experience might change, right? And so they might not be prepared for type of droughts or extreme precipitation that they're seeing. So I think it is important that we start to make sure that new regions are prepared for different types of warnings than maybe they've gotten in the past. Sorry, that's a lot, but yeah.
먼저 질문 줘서 아마 알고 있습니다. That is regarding for the third question.
Yeah. Okay. Yeah. Yeah, I think that this is an important question that I think a lot of countries are facing, actually, right? As countries become less reliant on traditional forms of energy production. In a way, as you build and scale up renewables, your grid is becoming more resilient. In one way, right? Because it's less dependent on a single type of energy generation, right? Which comes with volatility in different ways. Maybe not related to weather, but in terms of the markets or where oil and coal is coming from and geopolitics, right? And so it is becoming, as you diversify energy sources, you are bringing some resiliency to your electric grid. And so that's not, maybe that's not typically the motivation for why, there's an emphasis on getting renewable, in part because, of course, a big part of that is to reduce greenhouse gas emissions and to try to limit future climate change. But I think that inherently when you start to bring on a lot of renewables onto the grid, that there are examples. There's countries, in the United States, there's places like California that have brought on a lot of renewables and have faced challenges but have overcome them. So it's not, a place like Korea isn't starting from scratch. So there's use cases to learn from. But I think ultimately you have to design systems that acknowledge that there could be times, for example, during a heat wave, in which wind power will be low because it's a stagnant atmosphere, and demand will be high, and so you have to, you have to plan for those type of events, and you have to understand how that would affect your grid. Also, at those times, though, solar power would be really high, right? And so, I think that it's a different set of challenges, but in multiple ways, it's making your grid more resilient. Diversifying energy sources, to me, is increasing resilience. It's worth noting that the current, I don't know the details of Korea's power generation, and I understand that it's likely a lot of coal and natural gas, and some nuclear, but this is just, you've actually consolidated where your generation is happening, which means at some point there's going to be an event that impacts one of these facilities, right? And so in that sense, the grid is already dealing with these type of impacts. Even if you have more renewable, I think actually it'll geographically distribute things, which could be a good thing. And the final thing I would say, though, is that all conventional forms of energy generation, so coal, natural gas, nuclear, they all depend upon water. And what we've been talking for a while about changes in volume of water, or what happens when you don't get a lot, right? And so they are also susceptible to climate change impacts.
To know your opinion.
Yeah, I mean, I'll start by saying that, my opinion is that you need all types of energy generation, right? There is no, I guess for the holy grail, there is nothing that is going to be the end all be all. And so, in my perspective, every region, every country needs whatever is the right percentage breakdown that makes sense culturally, regionally, environmental-wise between hydro, renewable, solar, nuclear, and you also my honest opinion, you also need the ability sometimes to have natural gas plants because they do offer quick ability to, turn on if there is a peak event, and you need to. It's important to keep air conditioners on during a heat wave, and so you need everything. And so I think ultimately, then back more to the question is that building dams now with 2025 technology and infrastructure is probably different than building them 50 years ago. And so I think we've learned a lot about the environmental impacts. You could probably decide on areas that were better, more conducive naturally for it than others. And I think that it should be on the table, I guess, to answer the question. But it needs to be balanced with other forms of renewable. It needs to be balanced, right? If you're able to handle nuclear waste, it needs to be handled with that. There are opportunities, I think, to make hydropower work together with renewable because actually you can think of hydropower as a battery, essentially. And so if you're able to get power during the day from wind, and then you can use hydro in the evening, that actually makes a very resilient system. So I think there's opportunities to work together, I guess, on that.